We're here now. Another 7 weeks and we'll reach the autumn equinox point. Every 2 months, Mercury reaches its farthest point clear of the Sun. It's here that you have the best chance of seeing this little planet, so close to the Sun that it's usually hidden in its blaze. On rare occasions, Mercury's favorable position coincides with an extraordinary event. The Moon hides Mercury. 400 times more distant than the Moon, Mercury acts as a guide, showing us the slow movement of our satellite on its path around the Earth. We can see the Moon's thin crescent, which seems to move closer and closer to Mercury. Suddenly, before the crescent reaches it, Mercury disappears, wiped from the sky. The planet has been hidden by the unlit part of the Moon. And when the Moon drifts in front of the planet, hiding it from view, we can see that it's moving. After an hour, Mercury emerges from the right of the crescent. The first photo of our planet Earth from space, taken by astronauts in 1959. For the first time, everyone could see that we really are on board a spaceship traveling through the cosmos. It brings home to us that we have to look after our Earth, especially its most fragile feature, our atmosphere, the thin layer of gas that sheathes the Earth. Over billions of years, the atmosphere has continually changed, transforming the climate and conditions for life. For instance, its high oxygen content is quite a recent development, barely 400 million years old. That's only the last tenth of the Earth's history, when life was able to leave the seas. Looking at a much shorter period of 40 years, we've grown concerned about the increase in carbon dioxide caused by our activities. In the atmosphere, carbon dioxide prevents heat from escaping into space. This greenhouse effect is vital to our survival because it stabilizes the climate. But too much carbon dioxide in the atmosphere could increase the greenhouse effect and heat the atmosphere up too much. We have to avoid pollution if we want to take care of the atmosphere, which keeps us alive. For the first time, this photo showed us that the Earth did look as it does in our atlases. Lines of longitude and latitude allow us to locate every point on the Earth. New York, for instance, is 41 degrees north and 74 degrees west. These two measures, latitude and longitude, seem to be related, but their sources are surprisingly different. Latitude is measured from the equator, so New York is 41 degrees north of the equator, a natural reference. But that doesn't go for longitude. New York is 74 degrees west. But west of what? West of longitude 0, the Greenwich meridian. This meridian isn't a natural reference point like the equator. The Royal Observatory is at Greenwich near London. For centuries, all sea charts referred to the Greenwich meridian, so it became the International Longitude 0. So that's 0 point for the Earth's rotation in space. It's a reference for time too, because Greenwich Mean Time, GMT, has become the standard time. Space and time meet. Our spaceship Earth is crisscrossed by longitude and latitude lines, which allow us to pinpoint every spot. 49 degrees north, 2 degrees east, Paris. 41 degrees north, 74 degrees west, New York. A boat in distress gives its position as 4 degrees south, 122 degrees west, and it will be found at this precise address of the Marquesas Islands. Our standard international metric measurements, meters and kilometers, are also taken from the Earth. By definition, the kilometer is a 10,000th of the distance between the equator and the North Pole, a quarter of the Earth's circumference of 10,000 kilometers. It's another 10,000 kilometers back down to the equator on the other side, the same again to the South Pole, then another 10,000 for the last quarter. 4 times 10,000 is 40,000 kilometers, the length of a meridian circle. So it should be the same for the equator. But the Earth isn't a perfect sphere. Affected by its own rotation, it has flattened slightly. Centrifugal forces moving out from the center push matter away and create a bulge around the equator. So the equator is further from the center of the Earth than the poles, and longer than the meridian circles, 132 kilometers longer. 180 degrees from the Greenwich meridian, a very peculiar meridian runs down the Pacific Ocean, the international dateline. Let's say today at noon precisely on the Greenwich meridian it's Saturday everywhere on Earth. But in Honolulu it's 2 a.m. on Saturday morning. And in Tokyo it's 10 p.m. on Saturday evening. 2 hours later, it's midnight in Tokyo. Saturday's over. Sunday begins. In the dark blue zone, it's already Sunday. But in Honolulu, on the other side of the dateline, it's 4 o'clock in the morning and they still have the whole of Saturday before them. As the Earth turns, Sunday, in dark blue, spreads all over the globe, while Saturday, in light blue, shrinks away. At midnight, Europe moves into the dark blue Sunday zone too, along with Tokyo. While in light blue, in Honolulu, it's still Saturday afternoon. Then Sunday spreads all over the globe. Fortunately, this 180-degree meridian is in the middle of the Pacific. The islands separated by the international dateline are far apart, so it's less of a problem when your neighbors are a day ahead of you.